Welcome and thank you for joining. In this video, we'll look into a Pulley question. This is for grade 11 physics, Ontario curriculum. Let's get started by reading the problem first. So two masses, 3 and 8 kilograms, are attached by a frictionless pulley. So this is the pulley, and here are the two masses. So the mass M1 is 3 kilograms, and the mass M2 is 8 kilograms. So as you can see, the mass M2 is heavier, and that's why it's further down here on the pulley, and then M1 is lighter, so it is further up here. Now, we have to find the magnitude of acceleration and the magnitude of tension in the pulley. So we'll analyze the forces present, but one thing I wanted to emphasize or highlight first is that this is a frictionless pulley, which means that the force of friction is negligible. So in order to solve these problems, what we need to do first is draw a diagram of all the forces present in each weight or in each mass. So I'm going to get started with the mass M1. So it's best to draw the forces that are present on each mass separately. And I'm going to start off by first drawing the mass M1 and the present forces, which are going to be the force of gravity on M1. Now, the force of tension will be along the rope, and it will oppose the gravity. And the direction of the motion will be up because this is the lighter weight, which means that the resultant force or the net force of gravity and tension will make this object go up. And the way we measure that net force or the resultant force of gravity and tension is M1A. So M1A will be the force that will bring the object or the mass up. In a similar way, we are going to now take a look at the directions of forces. Now, because I see that this is going up, and gravity is down, I'm going to write a sign on each of them. That's my way of memorizing or reminding myself of the direction of the forces, which will help me actually build the equations. So since I have only one force down in here and these two are up, so I'm going to consider these two forces, M1A and the tension positive and gravity negative. So I'm going to write negative here and then positive for M1A. So next we are going to create the equation of the forces. So we're going to say that M1A, so this force in here, must be equal to the net force of gravity and tension. So must be equal to force of tension, which is in the positive direction, and then plus the force of gravity, which is in the negative direction, and that's why we have Ft minus Fg1. Now, in a similar way, we'll analyze the forces present in the second weight here. So here is M2, and I'm going to start off with the force of gravity on the mass M2, so Fg2. So the next force that is present is the force of tension. And then don't forget the direction of the motion here is going to go down because this is the heavier weight. So what that means again is that the net force of tension and gravity will be a force that is heading down because that's the direction in which the weight is going or this mass is going. And the net force, the way we measure this net force based on and thanks to Newton's second law, will be measured with the product of the mass M2 times A. Now, in a similar way, we're going to create the equation. So we have, in this case, we're going to have the directions first. So as you can see here, we have these two forces that go down, which means that, and only one force that is going up. So it would be easier in this case to consider these two as positives and the force of tension negative. And we are going to write them down as well because it makes it easier for us when we formulate the equation that connects these three forces. So we're going to have M2A, which is the net force that brings the object down, equal to the sum of these two forces. So M2A would be equal to Fg2, which we considered as positive, and minus Ft. So now that we have the two equations, we can easily solve for both acceleration and tension. Now remember that in a pulley, the tension will be the same throughout the rope, and that is because it's the same tension. The tension is created by both weights pulling on each other or pushing on each other, and that's why the tension will be the same. And the way that I want you to think of it is this, actually, and I find it a little bit easier this way, but let's put it on a diagram. So if it is two of you that are pulling, so if it is you and your friend, okay, so that are pulling on the same, no, are playing tug of war, let's say, and you're both pulling on the same rope, the tension on the rope will be the same throughout the rope. So because the rope will be tense, equally tense at any point and every point on it. Now, another thing I want you to think of is, let's say, for example, if your friend is pulling harder, is moving in this direction, then you will move forward as well. And the speed of your friend moving away from, you will be the same as your speed moving towards your friend. So, and that translates to acceleration. So the acceleration will be the same throughout the system here, and the tension will be the same. So what we are trying to solve for in this case is the acceleration. So I'm gonna highlight this, and that's our unknown. And the way we want to do this is by using a system of equations. So we can use substitution, elimination, doesn't really matter. Now the most common way of doing this is by using substitution. So I'm going to take Fg1 to the right side, so I have all the positive numbers, and that would be equal to the force of tension. And down here I have M2A. The force of tension actually is negative, so maybe we'll bring the force of tension to the left. So we have the force of tension in this case is going to be equal to the force of gravity minus M2A. So we have two equations for Ft. So we have this one here and this one here. We're talking about the same quantities, so we're going to equate the other sides on Ft. So I'm going to do something kind of neat here. Just going to copy and paste. It's a little bit faster. All right. And I'm going to say that these two Ft's mean the same thing. Bring them close to each other. So they must be equal as well. And now we're going to start solving for A. So if we want to solve for A, means that we're going to take them to the one side of the equation. M1A plus M2A will be Fg2 minus Fg1. Okay, now we're isolating A from M1 and M2. So, which would be equal to Fg2 would be M2G and Fg1 M1G. And that will be over M1 plus M2. And that is me getting ready to go to work. 1 second, I'll be alarm. So we'll substitute M1 plus M2 here. And this cancels out. And now we'll substitute all the numbers. So it is best to isolate for the variable we're looking for. And then do the calculations all in one step because that allows for higher precision. So the mass M2 is 8 kilograms, gravity 9.81, minus mass M1, which was, I think, 3 kilograms. Yeah. And times 9.81. And down here we have the masses 3 plus 8. And the calculation should take only one step, so all the work is in building the solution, right, step by step, and structuring your thinking process. So 8 times 9.81, and then minus 3 times 9.81. Divide this by 11, and we have 4.45 for the acceleration. Now, one last thing we have to be cautious of is the significant digits. So the values given here are correct to two significant digits. So the 4 and the 5 here will make a 5. So that means that the acceleration will be 4.5. And don't forget, obviously, the units, meters per second squared. And here we go. That's the acceleration. Now, next we have to find the force of tension. And for tension, all we have to do is use either equation. You use whichever equation looks simpler to you. I'm going to use this equation right here. So let me just copy it just because I can. And I will have M1A plus FG1 equals FT. So that means we have the weight of 3 kilograms multiplied by 4.5, and then plus FG1, which is equal to 3 times 9.81, which will equal the force of tension. And just simply calculate. Now, I encourage you to use this number as opposed to this one here when you calculate tension, because in this case, we are using a number that we have found, that we have calculated and rounded, right? And we don't want to create, solutions. If you use this number, it's going to be more accurate. And because using rounded numbers will provide more discrepancy in the final answer. So 3 times 4.45 plus 3 times 9.81, that will be the tension that the rope will have to bear. 42.78. Again, to two significant digits, don't forget. So finally, force of tension will be equal to 43 newtons. And this is it. So I hope you found the instructions useful, and thank you for following me. Bye for now.